modifying these products. So with that, I'm going to turn it over to Guy and let you guys hear what he's got to say and interact with him, and hopefully have the next great few hours that will make your life more productive.
All right. Hey, thank you very much, and I appreciate it. Good morning, everyone. Glad to have everybody aboard. Hopefully you guys can hear me, and can somebody confirm that you can see the PowerPoint slide?
We can.
Great. My Zoom meeting behavior is a little squirrely, so you guys have to stick with me here as I fight the battle. But we'll give it a shot, see how far it'll get. Anyway, what I thought I'd do is, before we get into the weeds and do anything technical, I would do a quick overview of some of the new product that we've got coming out, and try to explain the difference between the new Honeywell optimizer, the Spyder-7, Spyder-5 optimizer advanced, and now optimizer supervisor. So just to confuse everybody on the call, Honeywell is going to be renaming or rebranding a lot of our product, and everything is going to fall under the optimizer suite. By the end of the day, we'll have an Opto mouse and an Opto laptop and an Opto cup of coffee. I mean, I think everything's going to go optimized. But bear with me as I kind of walk through where we are, where we're going, and then we'll go under the hood of the 5.7 optimizer controller. Right now, our current Honeywell portfolio consists of the Honeywell JACEs and Cyper controllers that you're familiar with. That would be these guys right here. The IP-based controllers that are currently in the portfolio, the TC500 and the Spyder-7 VAV controller. And then we've got the MSTP RS-45 backnet controllers, the newer ones, the Spyder-5 Unitary, the Spyder-5 VAV, the Spyder-7 VAV, the TC500, same one, which can do both Wi-Fi or MSTP. And if you haven't seen it yet, the Spyder, what we used to call the Spyder-7 optimizer, or a Spyder-7 Unitary, it's now the optimizer. We're adding more products. We've got a Wi-Fi version of the Spyder-7 Unitary controller on the way, as well as T1L and Ethernet. We've got a PLC product, which you may or may not be familiar with. That's also been recently added to the portfolio. This is kind of the odd man out. It does not run Niagara. It is not a JACE. It is not a Cyper. It is a PLC, an industrial grade PLC, but it plays very, very well with Niagara. And then we've got the new Optimizer Advanced next generation JACE. We're not going to call it Webs. We're not going to call it Cyper. We're going to call it Optimizer Advanced. So what does it come down to? All of the products below the JACE Niagara line here, the 500, the 7, the optimizer, the 5, the 7, the 500, the optimizer, all of these come from the same core engine. They're all running essentially the same engineering machine under the hood. They are all part of what Honeywell calls the IRM family. Now, you're not going to find IRM listed as a product, but you will see the initials IRM in the older Honeywell engineering tools. When you open up Tritium Niagara, Honeywell Niagara, and you're opening up the engineering palette for the old Spyder-5 or the Spyder-5, it's going to be the IRM palette. This is going to be engineered with the IRM palette. Spyder-7 VAV is engineered with the IRM palette. You can't engineer the 500. We lock you out, but I can tell you that the Honeywell engineers that programmed it use the IRM palette, a version of the IRM palette. And the optimizer unitary controllers are all done with the optimizer. I'm sorry, the IRM palette. So not to confuse you, but everything down here in the second and third row, they're all part of the IRM. They're all part of the same family. If you know how to program a Spyder-5, you pretty much know how to program a Spyder-7. you pretty much know how to program an optimizer. This guy up here at the top right-hand corner, that is the new Optimizer Advanced. That's the Jace. So we're going to be talking primarily about the Spyder-5, Spyder-7 optimizer family, the IRM family here. But I guess since we got a few minutes, I would be remiss if I didn't give everybody a sneak preview on this. Is that okay? Get a little feedback? If you guys want to get a quick sneak preview on the Optimizer Advanced?
Yes, please.
Yes, sure.
Okay, so this is coming. The Optimizer Advanced is kind of a cross between a Jace and a Cyper. You're going to see some feature functionality crossover between them. And I don't want you to be confused with the new Jace 9000, which is the Tritium generic next generation controller. This Optimizer Advanced is the Honeywell branded next generation controller. Meanwhile, Tritium is coming out with their own next generation controller, the 9000. Under the hood, they're essentially the same thing. They're both using the same system on a motherboard. So the Jace 9000 and the Optimizer Advanced are going to be at the core, the same thing under the hood, but the Optimizer Advanced is going to be a different hardware platform. And as a Honeywell Webs contractor, you should be able to get both. You should have access to the next generation Jace 9000, as well as the Honeywell variant of that, the Optimizer Advanced. Some differences here between the traditional Jace 8000 and where we're going is you'll see that there's going to have different flavors of hardware. There'll be variations with different quantities of 45 ports, different quantities of Ethernet ports, and they're all going to have I/O fingers on the right for power and I/O expansion. Although you can't see it on the slide, here on the left, there's an RJ45 jack for an optional display. They're all DIN rail mount, and this is pretty standard of new Honeywell controllers. You put the little red clips down to click on the DIN rail. If you physically yank them up a little bit, you've got to jerk on them kind of hard. You can extend them out far enough where you can put a screw through them. So we've got this neat little standardized way of either going a DIN rail or a panel mount. Some contractors didn't realize that these can be pulled high enough away from the plastic where you can use them as a mounting ear. Here's the optional LCD display. It is color, but it's not graphical. You're not going to get a floor plan on there. You're not going to get an alarm. Well, you will get an alarm console, but you're not going to get a lot of color. This is very similar to the Cyper 50 onboard or remote display. So here's a little crossover between what we could do with the Cyper 50 and what we'll be able to do with the Optimizer Advanced. It'll have that optional display that can either be plugged into directly to it or remote mounted. And then the I/O is going to be introduced over the course of the next year or two. We've got a lot of plans for the different options for the I/O. And here's 3 of them that are shown that are prototyped. There's a generic I/O module. There's a I/O module with physical handoff auto switches. And there's a I/O module with electronic handoff auto with display. And you'll be able to buy these I/O modules a la carte to expand the Optimizer Advanced into what is effectively a Cyper controller. And not every I/O module will be available immediately, but there's plans for even a wireless version and potentially multiple protocols. Out of the gate, they'll talk Honeywell panel bus. We're looking at potentially doing a BACnet I/O module as well as a Modbus I/O module. And you'll note they all have little plastic tabs where they can physically connect to the optimizer to make it mechanically one large controller. The model with the display will allow you to not only control and do handoff override over the output, you'll note that we can also read the input values. So you'll be able to see the I/O value right on the I/O module. Kind of cool. They'll slip on the DIN rail, and they will carry with them the 45 and the power. And if you have to go away from the DIN rail or remote mount, there'll be a little screw terminal adapter you'll plug in there and you can remote mount the IO either on the next DIN rail down or 1,000 feet away because it's an RS-45 trunk. So that was the sneak preview of the next generation controller. I don't have a whole lot more in the way of details that I can share at the moment. It's still going into beta, or hasn't quite gone into beta testing yet. I expect we'll see an announcement in the third quarter of this year as far as initial availability. But it looks to be a nice a la carte, buy what you need, much faster, much more powerful next generation Gs. And depending on how you configure it, potentially a next generation Cyper. I've heard of no plans to discontinue any of the existing controllers. The 10, 30, 50, 8000 are still being built, but that's the next product coming down the line. Any questions on the sneak preview before we start talking about the 7 and 5? Oh, y'all are a quiet bunch. Feel free to jump in and interrupt at any time. Nobody asked, but the next generation controller will only run 412 and up. So heads up on that. If you're getting really excited about the Optimizer Advanced Jace 9000 controllers, keep in mind that'll be a 412 variant. All right, shall we continue? All right.
Yes, yes, thank you, guy.
Okay, so the main star of the show today is going to be the Spyder 7 family, the IRM family, the Optimizer family, Spyder 5 family. They're all the same. They're all under the hood, the IRM family. We're going to look at the hardware first, and I'm not going to go over every point. This isn't a Spyder 7 training class. We do offer that. That is a 3.5 day or 4 day session on the Spyder 7. So we're not going to learn everything that we can learn in 4 days and 2 hours, but I will do a couple of quick highlights for you. First of all, I can't see everybody. Usually I do a show of hands. Has anybody on the call had any experience with the Spyder 7 VAV yet?
No.
Okay. You're going to be excited about it. How about, let me ask another question. Has anybody had any experience with the Spyder 5 VAV? Nobody?
Love those things.
Okay.
Sold
Well,
a bunch of them.
I'm glad you have. They had some definite growing pains. The Spyder 5 came from mainly a European design team and was an evolution of the Spyder 5 unitary controller, which was a fan coil unit controller sold in England as the Merlin. I mean, this thing has kind of a tortured past if you go back about 4 or 5 years and figure out where, how we got to where we are today. It all started with something called the Merlin, which was an individual room monitor. That's IRM. So the IRM family, the original Spyder 5 unitary, came out of a fan coil unit project out of, I believe, England. And then the Spyder 5 VAV variant was more of an international effort. And one takeaway of the older Spyder 5 controllers is they had way more memory, way more capability than a Spyder-classic, but they did not do anything over IP. They were strictly and are strictly BACnet MSTP controllers. So the Spyder 5 AV, the Spyder 5 unitary, strictly BACnet MSTP. The Spyder 7 is still part of that same family. They're still kind of running the same processor style, same memory, same engineering style, but they have more memory. They have more capability physically under the hood. They're beefed up, and they are available with variations of BACnet over IP as well as MSTP. So you'll be able to order whether you want the IP version or the MSTP version. So that's the number one difference between a 5 and a 7. 7s have got more memory, they've got more power, but the big difference is right here. Only the 7 family is available with an IP variant. And depending on which 7 you're looking at, it may be BACnet over IP with an RJ45 jack. The new optimizer unitary controller offers the Ethernet jack as well as something called T1L. We'll talk about that in a minute. And we're working on a Wi-Fi only version. So you'll have actually eventually 4 flavors. You'll have BACnet over twisted pair, BACnet over Ethernet, BACnet over T1L, and BACnet over Wi-Fi. And this is all going to be part of the Spyder 7 optimizer. The Spyder 5, like the Spyder 10, 30, and 50, and 8000, we're going to continue to make them. But I think going forward, you're going to be more interested in the Spyder 7, or what we're changing the name to optimizer. So today, the Spyder 7 VAV is labeled Spyder 7, but don't be surprised if next year we reintroduce it as the optimizer VAV. So the big obvious difference, as I just mentioned, was these guys are available with an IP variant. There's 2 other differences that set it apart from some of our earlier VAV product. Not shown on the graphic, the actuator has a position feedback. That is a big, big, big deal. This is Honeywell's first VAV controller where the damper position is measured directly off the actuator, which means technically you don't need to do a float out sync anymore. I know where that damper is at all times because I can read that value directly off the actuator. So this can eliminate the need to do a float out sync. The other difference, obviously, other than the Ethernet, is these have got a user replaceable 0 to 2 inch bidirectional pressure transmitter. That's a big jump over the older Spyder-classic, and this is our first controller where the airflow pickup, the bidirectional pressure transmitter, can be user replaced. We've had situations where VAV controllers were installed, the airflow pickup got contaminated or damaged or dirty. And instead of ripping out and replacing the entire controller, now you can pop this off. The plastic is designed to be pulled right out with your thumb, pop the cable off, plug in a new one, and you're good to go. No rebalancing required. Hardware-wise, what should be kind of obvious from the picture, there's also a boatload of I/O here. We've got 7, get it, Spyder 7, 7 universal I/O inputs, we'll talk about in a minute, plus 5 digital outputs, plus Silk, plus Modbus. This controller, the VAV and the unitary Spyder 7, all incorporate both a Silk subnetwork and a Modbus subnetwork. So if you look at the picture here, I mean, this is way more than what you typically find in a Honeywell VAV controller. It's got a boatload of I/O. It's got Modbus. It's got the Ethernet, the user replaceable pressure transmitter, the feedback on the actuator. So pop quiz, is there anybody on the call who's ever put any Honeywell VAV controller, whether it's a new one or a Spyder-classic or whatever? Have you ever put a VAV controller on an air handling unit?
Yeah.
Yeah,
Yes,
these
sir.
things make great air handling unit controllers. If I'm doing a project, maybe a school job, and I've got some little split systems with an outdoor air damper, I mean, this is probably my go-to controller because, like the Honeywell Spyder-classic, it comes to you as a blank sheet of paper. We designate it as a VAV controller, but you can put it on anything. You could program it to do pretty much whatever you want. But if you do put it on something like a classroom air handling unit or a small rooftop unit, this actuator is a 44 inch-pound actuator. You do have to mount this control on a damper shaft. There's no provision to remove the actuator. So that's kind of a requirement. If you're going to put this on an air handling unit, you really want to have a damper, you put it onto, because that's going to be about the only way you're going to physically install it. So if the unit that you're installing has a damper shaft and that you can turn with a 44 inch-pound actuator, this may be the best bargain to go with. Not only does it come with the actuator, with the feedback baked into it, you also have this pressure transmitter here, which even if you're not doing a variable air volume, is a great way to do dirty filter alarming. And if I'm already monitoring a differential pressure across the filter, I don't need to do a current sensor. I don't need to monitor the fan status. I'll know if the fan is running whenever there's any pressure drop across the filter. So I can use this input here as our fan status / dirty filter alarm. That's a pretty common way to be very competitive in the market. If you can take advantage of the built-in actuator, if you take advantage of the pressure transmitter, you can reduce your peripheral cost, come in with a very low cost controller. And even after you do all that, you still have 7 IO plus the silk plus the Modbus. There's a ton of data you can bring into it above and beyond what you might do on a VAV controller. We're going to get under the hood here in a minute. This isn't going to be death by PowerPoint, but I just want to kind of set the stage here for the new controllers. So from there, introducing the Honeywell unitary controller. So this is the Spyder 7 unitary, now renamed Optimizer Unitary. It's available in 2 flavors, small and large. That is a small, and you add 16 or 8 more IO to it to a total of 16, and it becomes a large. The only difference between the small and the large is the number of purple universal IO terminals. Whether it's a small or large, they're all 24 volt AC DC powered. They all have a 20 volt DC auxiliary output if you're doing 4 to 20 milliamp output, or sensors. I'm sorry, if you're doing 4 to 20 milliamp sensors, that comes in handy. These orange terminals are your digital outputs, and whether you're buying a small or a large, each one of them comes with 4 solid state relay outputs and 4 physical relay outputs. These solid state relays are what we used to use triacs for. I guess technically a triac could be called a solid state relay as well. The difference is that on the new controllers, we've gone to a MOSFET, which is a type of transistor. It's rated at an 1.5 amp, 3 amp surge. So these orange terminals here that I'm highlighting, they're no longer triacs, they're now MOSFETs. And although it's not shown on the photo, they come with a little jumper pre-installed to get 24 volt power to them. So you don't have to run any wires over to the other side of the circuit board. By default, when you turn on any of these 4 solid state relays, you will by default get 24 volt out. If you don't want that, you can pull the jumper. In addition to the solid state relays, the physical dry contact relays have a common normally open and normally closed, and you're going to love this. They're rated at 250 volts at 10 amps. So you can switch line voltage directly through the unitary controller without the need of adding ancillary, ice cubes or DIMMs or DIN rail mounted or PAMs or rib relays. You can switch line voltage directly from the controller if you're inclined to do that. This red jumper here physically brings all the relays to the same source common, so that if you just want to run a 24 volt or 120 or 240 volt pot into it, you can have them switch that directly, or you can pull this jumper out and do each relay individually. If you are running line voltage, you will want to buy the optional terminal covers that cover up the terminals, keep you from getting shocked. And the best is yet to come. These are the first Honeywell controllers that offer not 1, not 2, but 3 different communication options. You do have to buy which one you want. So if you buy the MSTP, you don't get IP. If you buy the IP, you don't get P1L. You have to pick based on the model number which communication protocol you want. Backnet MSTP is what we're used to. That's twisted pair over 45 bus. Backnet IP is two Ethernet ports. They are built in, bridged together. So it shares a single MAC, a single IP network and subnetwork TCP/IP, IPv4 address, but they are two physical ports, and it'll support either 10 or 100 megabit speed. And something new, BACnet over Ethernet over a T1L, BACnet IP over T1L. Does anybody know about T1L? Anybody on the call know what T1L is or had any experience with it yet?
That's a twisted pair Ethernet, isn't it?
It is. It's not a Honeywell protocol. This is a standard IT protocol, which is Honeywell. I believe we're the first manufacturer to make this an option in building automation. So we're pretty excited about what we might be able to do with T1L. We're going to deep dive into T1L here in a minute. But wait, there's more. Like the VAV controller, the optimizer unitary controller includes a Silk and a Modbus port. The Modbus port on all of the new controllers is a Modbus master port. So the controller itself will always be device MAC 0. There it is the master, but it will talk downstream to things like Honeywell VFDs, Honeywell meters, Honeywell IQ sensors. And if you think about this for a minute, this is another big deal. If I'm doing a VAV air handling unit, I probably have a VFD controlling it. If I have a VFD controlling it, and I put this on the air handling unit, instead of using an analog output to drive the VFD and then maybe a digital output to turn it on, a digital input for alarm, instead of using up my precious I/O to drive my VFD, which is 2 feet away in a cabinet, I can run a 45 bus to it, talk Modbus over MSTP to the VFD, and pretty much everybody's VFD will do that. That's pretty standard in the industry. And instead of using my I/O to get 3 or 4 data points in and out of the VFD, I'll talk Modbus and maybe get 30, including things like the fault code or the KW, turn the VFD into a submeter and get the KW and KWH off of it. So if you can talk Modbus downstream to the VFDs on a VAV air handling unit, you're probably way ahead of the game. And if I can use Modbus in lieu of the physical I/O, then maybe I don't need the more expensive large controller. Maybe I can get away with a small version of the unitary controller and also be way more competitive. We're also going to talk about the TR50, brand new wall module. It's available today. This can also be configured to talk Modbus and can bring all kinds of data in from these guys into the new Honeywell controllers. Let's do a little deeper dive into the portfolio. Currently, there are 12 part numbers, soon to be a few more when we add the wireless Wi-Fi version. But there's a small and a large variant, and then there's the MSTP variant, the IP variant, and the T1L variant. And in addition to that, every small or large variant is available with or without a Bluetooth option. So even if you're doing the twisted pair version, you can order it with or without Bluetooth. The B here is for Bluetooth. You might be wondering, why would I want Bluetooth in a controller? Well, these are the unitary. So you would need to have some kind of Bluetooth app for the unitary to make it useful. And we're working on that now. The VAV controller that I showed earlier also shares that same option. You can buy it with or without Bluetooth. In the VAV version, it's a big deal. You'd want Bluetooth to do balancing. So the Bluetooth will only be of benefit to you if you have a companion app. For the VAV controllers, that's the balancing app. For the unitary controllers, we're working on a checkout and test app. More to come on that. I was actually on a call this morning about that. So it's not quite ready for public release yet, but we are working on the Bluetooth checkout and test app for the unitary controllers. So back to the new stuff. T1L is 10 megabit backnet over IP, but instead of over a Cat5 or Cat6 cable, we're using twisted pair. Now it says LAN daisy chain. It is not LAN, but it can use LAN wire. It does not have to be the twisted shielded RS-45 cable. You can run it on the twisted shielded cable, but twisted shielded cable, because of the shield, generally is more expensive than the lower cost LAN cable. And T1L will work just equally as well on either cable. To convert your Ethernet Cat5, Cat6, RJ45 connection to T1L, you will need one adapter per T1L network. The adapter is simply a media converter. It is not a router, it's not a switch, it's not programmable, doesn't have an IP address, it's just a box with Ethernet on one end and T1L out on the other. And Honeywell manufactures that because we wanted one that was 24-volt AC powered. So Honeywell is manufacturing a adapter that will let you convert a Cat5 bus connection to or Cat6 to a T1L. This doesn't do the speed conversion, but T1L devices, the ones that we've got, talk at 10 megabits. So the T1L bus will appear as a 10 megabit port. So through this box here, going back to your router way over here, it'll see that as a 10 megabit connection and should auto moderate accordingly. So you need one of these per T1L network, and the connection to the optimizer controller is in and out. You come in on T1L1, you go out on T1L2, and there's a bridge between the ports in the controller. Let's look at how this compares to Ethernet and RS-45. So in RS-45, you've got typically about 40 controllers on a trunk. You could put technically more than that on there, but that's a good round number for just about any field controller, LAN, BACnet, Modbus, Honeywell, not Honeywell. At the speed that we normally run here, typically 78 kilobaud, you don't want more than 40 controllers on your trunk. And if I come out to your job and I see you hung more than 40, I'm probably going to fuss at you. Sometimes we've got to do a lot fewer, but 40 is a good number for the newer controllers, and that hasn't changed. The connection is a daisy chain only, and it's a twisted shielded cable, and the speed, as we know, is about 78 kilobaud. Ethernet, if you were to do a daisy chain, because we're doing an apples to apples comparison here, normally you wouldn't do a strict daisy chain with Ethernet, but if you did, one of the advantages, of course, is the speed. We're running at 10 or 100 megabit, and we're not limited to 40. In theory, you have 254 devices on a daisy chain. T1L kind of gives you the best of both worlds. You've got the higher speed of 10 megabit, but you also have the ability to do well over 40 devices on a daisy chain. And the twisted pair doesn't have to be shielded. It can be just regular lower cost twisted cable. So T1L is giving us the speed of Ethernet and the capability as far as the number of devices of Ethernet with the lower cost of a twisted cable. The real change, the real difference here is the protocol. MSTP, we'll talk BACnet over MSTP. Ethernet and T1L both talk BACnet over IP. And although we aren't doing it today, you can pretty much figure that BACnet IP secure is going to be coming in these controllers. So this gives us the option to do the BACnet secure protocol, the encrypted protocol, when that's fully released. We're not quite there yet, but we're looking at BACnet secure as being a future enhancement for all of our BACnet IP controllers. When it comes to fail-safe capability, There's some other differences, and we need to explore that real quick. BACnet over twisted pair, RS, anything, any protocol over RS-45 twisted pair is inherently fail-safe. If you lose the controller, the remaining controllers continue to function because the bus is continuous, because the wires are tied under the same terminal. So if you lose one controller, everything downstream continues to work. In the world of IP, if you did a daisy chain, which is not a good idea, but if you did a daisy chain and you lost a controller, everything downstream would typically fail because the Ethernet connectivity, the bridge would be powered down, it wouldn't function. The connection downstream would be lost. So we don't normally do that, right? I said, this is a bad idea. The way you mitigate that is either you home run everything. If you home run everything and you lose the controller, everything else continues to function. Or, or you do a loop. In order to do a loop where you're going in and out, and you come back to your router, this loop configuration gives you an alternate data path. So if you lose one controller, the remaining controllers in the loop continue to function. It's not perfect. If you have multiple losses, you're liable to lose controllers in between. And it does require a IP feature called RSTP, Rapid Spanning Tree Protocol, which is basically the acronym for a self-healing loop. So your gizmo out here, which might be a Honeywell Cyber 30, it might be a Cisco router, it might be some other brand product. This RSTP is a feature of the router, not a feature of the Honeywell controllers. But if you have an RSTP router that'll let you go in and out with the loop, we can mitigate a lot of the fail-safe issues with Ethernet. Now, if we compare that to T1L, and we'll look at T1L with a twisted pair. With T1L and with twisted pair, when you lose the controller with the twisted pair, again, we've already said that you lose everything. Now, some of our friendly competition will try to mitigate this issue with relays. They've got a little fail-safe set of relays right here, so that when the controller goes down, the relays fail shut and communication is bridged from this controller to that controller. The fallacy with putting a fail-safe relay on an Ethernet connection is Ethernet maxes out at about 300 feet. So if my distance between controller 1 and controller 3 is greater than 300 feet, fail-safe relays aren't going to do me any good. If I lose my controller in the middle, I'm dead in the water downstream. So although the idea of the fail-safe relay to bridge this broken controller, the concept is good, but it really doesn't behave very well in Ethernet. If I've got 2 failures in a row, I'm pretty much out of luck. T1L is spec'd 4,000 feet node to node. Now, if you read the Honeywell literature, we tell you this is 1,000 feet. I think we're being very conservative in our own literature. The T1L spec says I can go 4,000 feet from one node to the other, but I'll play nice with the Honeywell hat on. I've got 1,000 feet distance between active nodes minimum. So we should be good. Even if I have 1 or 2 or 3 failures, chances are I'm less than 1,000 feet between 2 working nodes. So T1L in a low-cost daisy chain is inherently very good about mitigating the risk of multiple controller loss and still maintaining communication. So it has a lot of advantages here compared to running Cat5 home runs, compared to running Cat1 daisy chain, or even running a RSTP loop. If you don't have an RSTP router, that's not an option either. Comment, question about T1L? What do y'all think? Nobody?
I think there's a lot of retrofits in the future.
Maybe. Now, I'm glad you said that because I want to caution everybody on the call. If you read and listen to some of the internal or the external Honeywell marketing, Honeywell likes to tout T1L as a replacement for a lawn. Be very, very careful with that concept. First thing you need to know is you cannot mix T1L and lawn. So if I have a bunch of lawn controllers and one of them fails, I can't rip it out and put a T1L controller on the lawn trunk. It isn't going to work. The other thing to keep in mind is that although it can work on an existing lawn cable, all the lawn controllers would have to be yanked off that bus and all converted to T1L. And it's only going to work if your lawn controllers were wired in a daisy chain. Unlike T1L, lawn allows a free topology. And if you have an existing free topology lawn trunk, it's not going to convert to T1L. So Honeywell is very optimistic about saying, oh, this will replace lawn. And it's more like, maybe you won't have to run a new T1L trunk. You might be able to reuse your existing lawn wire, but everything on the bus has to be replaced. And you better make sure it was a daisy chain to begin with. That being said, that probably covers a lot of lawn networks, but just a caution, it's not a direct replacement for a lawn controller, but it may save you substantial cost if you don't have to rerun a new trunk.
Guy, how does
Yeah.
T1 on a shielded cable?
It's okay. You can run it on a twisted shielded. It's spec'd for both for RS-45 grade cable as well as lawn grade cable. And as far as I know, there's no difference in the
So I
performance
wouldn't
or maximum.
get the low cap like I'm having to do for my BACnet RS-45 now.
Well, it's RS-45 cable. It doesn't have to be specifically low cap. It just has to be rated for RS-45. So yeah, if you're running T1L, you can look at, I don't have it in front of me, but if you were to run standard lawn cable, I don't know the capacitance off the top of my head, but it's rated for that. It's also rated for standard RS-45 cable, and it may be rated for other generic cable as well. But yeah, if you want to save some money, I'd probably buy the lawn style cable. Does not have to be shielded. It is polarity sensitive though, but it doesn't have to be shielded. That help?
Yes.
All right. Oh, and by the way, the T1L is currently only available on the unitary controller. I expect to see a T1L version of the VAV controller, the Spyder-7, probably next year. And that's usually the first feedback I get on T1L. When people talk about, oh, I like the idea of T1L, but my job's got 200 VAV controllers. It's okay, we're working on it. So don't be surprised if we don't bring out a T1L VAV variant next year.
I do have one more question about the T1L controllers.
Okay, I'm not seeing any questions on the screen here. I don't know where my actually I don't know where my screen went. But okay, what was the question?
Just about all the devices in the chain. How are they addressed? It's all coming in.
They're IP. They're BACnet IP. So just like the RJ45 Ethernet cables that come out of the box DHCP, and then you configure them with your desired IP address. Typically, what you're going to do is you'll discover them with DHCP, and then you will change them to a static or a fixed IP address.
Got it.
Yeah, from the Jason's perspective, it's BACnet over IP. It doesn't know what T1L is. Again, T1L is an electrical thing. It's not a protocol thing. You're coming out of the Jace or the Cipher or the LAN, the network switch or router with a piece of RJ45, and instead of plugging RJ45 into the controller, you plug RJ45 into the adapter and run twisted pair out. But the protocol hasn't changed. It's BACnet over IP, hopefully BACnet IP secure after that. Okay. So let's go ahead and continue with the new product, and then we'll do the dog and pony show here with the hardware and the software. So has anybody used the TR50 yet? So
No.
nobody on the call has seen or used the Honeywell TR50? I take that to be the answer. This is available now. These are a new product that was introduced earlier this year, and you should all know about it for two reasons. They play really, really well with the Spyder 7, Spyder 5 optimizer controller. So they work well with that. They also work perfectly good with Niagara. And depending on which version you get, they're also backwards compatible with Spyder-classic and can save you some money compared to the TR40. So what are they? They are a, or what is it? TR50 is a family of indoor air quality sensors. They are not wall modules. There's no set point. There's no override. These are sensors only, similar to how the TR40 is a sensor where the TR42 is a wall module. Real quick before I jump into that, Chris, the T1Ls have a fail-safe jumper relay that shorts the bus through on a failure. So they're internally jumpered on failure. He had a question of whether or not the T1Ls were jumpered or not. That goes back to that fail-safe thing. Anyway, back to the TR50. So the TR50s are sensors only, they're not wall modules. Like the TR40, we have a variant that does temperature, humidity, and CO2, but we've also have a 5-point variant, which will add volatile organic compound and particulate. We also have two flavors of display, the alarm bar only, or the alarm bar coupled with a numeric display, where the numeric display bars are somewhat configurable. And where did my PowerPoint go? Here you're going to like this. They all come out of the box with 3 protocols. They can talk Silk, they can talk BACnet MSTP, and look at that, they can talk Modbus MSTP, and then we know where we can use that. So if you buy the 3-point and you configure it for Silk by wiring it up to these terminals here, and you configure it for Silk, it will emulate a TR40H CO2. So the 3-point variant is a direct replacement for the TR40H CO2, and it costs less money. So if you're adding CO2 to a project, an old Spyder-classic or some other controller, and you were buying the TR40s, we can get you more competitive now with the TR50. Configure it for Silk, set the dip switch, and your Spyder won't know any difference. If you buy the 3-point, you also have the option to do MSTP or BACnet. If you do that, if you run BACnet or Modbus, you will need to provide 24-volt power as well as your bus. If you're doing the 3-point Silk, like the TR40, we can power it directly off the Silk trunk. The 5-point variant, it is available with Silk, but I have nothing that'll talk to it over Silk yet. We're going to have to update the firmware so that I will eventually be able to put the 5-point Silk on a optimizer or a Spyder 5. But currently, the 5-point, if you configure it for Silk, the controllers, the Honeywell controllers don't know how to talk to it. So if you want to bring this into a Honeywell optimizer, Spyder 5, Spyder 7, or a Jace or a Cyper, you'd use BACnet or MSTP. You will provide 24-volt power, but now you've got all the data, including all the VOC and particulate data.
So guys, that another BACnet address on my Jace?
Yes, if you're bringing it in directly to a Jace or a Cyper, it would either be a BACnet or a Modbus device, and it would count against your device and point total. If you bring it in, go ahead.
No, if I bring it directly in through the Modbus on a controller.
Yeah, if you bring it in through a Modbus port on a Spyder 5 or 7, the answer is no, because it's just like a Silk device. It's just something downstream. So if you're talking Modbus to a Spyder 7 or an optimizer fan coil unit controller or unitary controller, you could bring in 40, 50 objects from this controller into the Spyder. In fact, you'll see that I've got one running behind me, and I'll show you that live in a minute. And none of that counts against your Jace point count. The only things that count against your Niagara point count are the BACnet objects that you bring over. So to
And
answer
how-
your question, yeah, this
that-
will let
that-
you
Put on a controller.
say again.
How many of these sensors could we put on one controller?
We recommend no more than 5 devices or 150 points per optimizer. I don't know if that's a hard number. I've yet to get a firm answer from Honeywell engineering. I asked them, I said, is that a hard limit or a recommended limit? And the answer is yeah. I don't think they know either. So we spec the Modbus port for 5 devices, 150 points, whatever comes first. I've brought in a fully loaded Honeywell VFD and a fully loaded IQ sensor. The Honeywell Spyder 5 didn't even break a sweat. So I'm thinking it's more of a soft limit, not a hard limit. And just to show you how the configuration is done, you throw the switch, depending whether you're doing 45 or silk, and you use these 2 addresses here, 1 and 2, to set it for silk, Modbus, or BACnet. So this is the electrical switch, and 1 and 2 is the protocol switch, and then you've got the MAC address here as needed. Excuse me. These displays can be disabled. You can turn them off. You can change them from being a multicolor to a white display. You can pick which values get displayed, if they rotate, when they dim, how low they dim. You've got a ton of configurations for how these present themselves into the space, and including the levels of alarm that'll change the color from green to yellow to red. By default, they'll probably work exactly the way you want them to do. But if you have a customer that says, I don't want this to change color, you can turn it white. If you have a customer that says, you know, I want my CO2 alarm, but I only want alarm over 1500 ppm, then you can go in there and configure the alarm limits and delays. All of that alarming, all of that time delay, all of that limiting has to do with the local display and has nothing to do with the silk BACnet or Modbus data coming out of it. So if it's showing a local alarm here, it doesn't mean that the BACnet point is an alarm. You can use Niagara to put your own alarm extensions on there. All of the configuration is done via BACnet or Modbus points. Currently, Silk, the current Silk firmware does not have any configuration in it. So if you take one of these controllers and hook it up to Silk, the same way you would a TR40, you either live with the default values, or you, before you install it on Silk, you hook it up to some BACnet or Modbus port and configure it the way you want. It'll retain the configuration. If you tell it my high limit for my PPM is 40 instead of 35, it'll maintain it. But this is just a capture, a screenshot showing some of the probably 100 configuration objects that are available. Okay, what do we think? That useful?
I have a quick question.
Yeah.
Back on that TL1,
Mhm.
can you use that to go to the secondary port on the Jace? And if so, can you tunnel to the controller through the Jace?
Well, it's BACnet over IP. So what you would have, depending on whether Jace is doing a bridge or an independent, would really depend on how you're configuring it. From the Jace's perspective, it's just a BACnet over IP controller.
Okay. Because I think I was told at some point that if anything's hooked into the secondary port, that the primary, if you're tunneling through the primary port, like you're just remotely connected to a Jace, that you can't actually tunnel to anything on that secondary port. I don't know
Well,
if-
tunneling is a Niagara thing. So where we talk about tunneling, we're talking about, I've got, a Jace 8000 connected on Ethernet RJ45 port coming into port 1, and port 2 might be connected to a Cyper 30 or a Cyper 50 talking Niagara. That's what I call tunneling. I'm using the Jace to talk Niagara through it. And that's
Correct.
really not this application. The controllers are not Niagara controllers. Let me demo. Let me share my screen again, since I turn it back on. Share screen. Okay, I'm sharing my screen again. This should look familiar. This is a Jace, right?
We aren't able to see it.
You're not seeing it. Oh,
No.
let's see. I guess you got to hit the share button. How about now?
Yes.
Okay. So I'm connected to a Jace, and on my Jace, I've got a BACnet network. And on my BACnet network, if I go to the Spyder or the default Venom view, if I just double click on the BACnet network, the default view. Sorry for the small size here. I hope you guys can see it. This is the default Honeywell BACnet device manager view, where it shows some Honeywell controllers downstream. If I change the view to you're going to learn all about this in a minute, the IRM BACnet device manager view, same controllers, still talking BACnet downstream. Here's one of the new Spyder 7 MSTP controllers. So I'm not tunneling to it, I'm talking to it over BACnet. So the Jace sees this optimizer Spyder 7, unitary controller the same way it sees that BACnet Spyder. So here's a BACnet Spyder. Here's a optimizer controller. It's just another gizmo on the twisted pair. If you look at my Ethernet port, I've got a Honeywell Spyder 7 VAV controller. It's on network 10,000. That's my Ethernet Spyder 7 VAV. It's right here. And that Spyder 7 VAV that we're looking at, like the MSTP controller, I'm not tunneling to it. I'm just talking to it over BACnet over IP. If I go back to that BACnet device manager view that I was just looking at, there's nothing on this BACnet device manager view that would tell me, other than the part number, that I'm talking T1L. I happen to know that I'm not talking T1L, I'm talking BACnet over IP over RJ45. But if I took my RJ45 connector and I plugged it into a T1L adapter and did a discover, this is what it would see. It would see a BACnet IP controller. That help?
Yeah, I'm just kind of new to these, so I didn't know how are the controllers programmed? Is it Niagara 4 or is it something else?
They're not Niagara. So are you familiar with the Honeywell Spyder-classic?
Not particularly.
Which for some reason just went down when I clicked on it. The Honeywell Spyder-classic has been our go-to field controller for years. The engineering tool for writing the program, here's a blank sheet of paper, is built into Niagara. We use a palette. We don't use kit control. If I try to program a Honeywell Spyder with the Niagara engineering tool, if I try to take an OR block and drop it on a Honeywell Spyder, it's going to say, you can't do that because this is not a Jace. It's not Niagara. Unlike our competition, and I'll pick on Train or Delta or Johnson or Distech, I don't have a Windows program for programming a Honeywell Spyder. I don't have a Windows program for programming a Honeywell Spyder 7 or an optimizer. All of the Honeywell field controllers are programmed with tools that we bake into Niagara, which is a
So it's a
big
module,
difference.
basically.
It's a jar file, it's a module,
Okay.
and it's built into Niagara. And the reason we do this, and this is for you guys that haven't gotten this story, this is maybe the most important thing I'm going to tell you all day. The reason we do this is so that we leave the tools behind. When you, as a Honeywell contractor, install a Honeywell Webs project, a Honeywell project with Honeywell controllers, Honeywell cases, Honeywell supervisor, it's Honeywell You're leaving all the